Hello everyone, in this lecture let us see what is electric arc welding, what are the different types of arc weldings available, what are the different methods available, what are their advantages and disadvantages. First of all, let us see what is electric arc welding. So electric arc welding is a process of joining two metal pieces or melting of metal due to heat developed by an arc stuck between an electrode and the metal to be welded, or between the two electrodes. So what is happening here is, because of the heat developed by an arc with the help of an arc, so if the two metals to be joined will be melting, or due to that heat may be between two electrodes or an electrode and the surface and a metal surface, right? So what is happening here is, some amount of electricity will be flown through the metal piece or an electrode, due to which an arc is developed. Due to that arc, heat is developed. So when the two metal pieces to be welded are withdrawn, so the gap between those gets ionized. Due to the ionization of the gap, so there will be a conducting medium for the current through the air gap. So due to which air is flown, so due to which some amount of heat is produced. That amount of heat will melt the metal to be welded. So that is what happening in electric arc welding. So these are the factors that affect the length of the arc. How much amount of length of the arc is to be taken for a proper welding. So surface coating and type of the electrodes, position of welding, at which position the metal to be welded is placed, or amount of current used, how much amount of current is provided for the welding purpose. These three are the major factors on which the length of the arc is depending upon. So in this process, an arc is produced by bringing two conductors, that may be an electrode and a metal piece, connected with a suitable source of electric current, that may be an AC current or DC current. So they will be brought together with the help of that electric current only for few seconds, and after that they will be separated by a small gap, due to which an arc is found between the two contacts, that is electrode and the metal piece, right? So due to which ionization is taken place between the contact area, which gives immense heat. So that heat, due to that heat, what happens? Due to that ionization is formed, that heat is utilized to melt some part of the metal piece and the filler material, and thus the weld is completed, right? The temperature in this kind of arc welding is about 3600 degrees centigrade. So this is about 3600 degrees centigrade. So in this kind of welding, there is no pressure acting upon in any way. So this kind of welding is called as non-pressure welding. As there is no role of pressure anywhere, it is known as non-pressure welding. So the voltage in arc welding varies about 70 volts to 100 volts on AC, whereas 50 to 60 volts on DC, right? So coming to the applications of electric arc welding, these are used for joining metal parts and repair of fractured casting, right? So, or if any part of the metals are worn out, this kind of arc welding also can be used. So for removing any decompositions on the metal pieces also, this kind of welding can be used. Now coming to the classification of electric arc welding. So there are different categories or different types of electric arc welding. Let us see all of those one by one in detail. Now coming to the metal arc welding. So it is an arc welding process where the welding is brought about by heating the workpiece. This is the workpiece with an electric arc. Here the electric arc is formed, set up between a flux coated electrode. This is a flux coated electrode and the workpiece. This is the workpiece. Right here what is done is, with the help of electrode holder, an electrode is holded, which is coated by some amount of flux. So here this flux coated electrode acts as a filler material. In metal arc welding, this electrode is taken such that it is made up of same material such that the metal to be welded. What happens is, when this electrode gets heated, that is flux coated electrode gets heated, so it forms an arc between the workpiece and the electrode. Right, so due to the heat formation due to the arc formed, what happens is, this flux coated electrode metal gets melted in the form of droplets and it gets deposited on the workpiece to be welded. So in this case, in this way, the flux coated electrode acts as a filler material to weld the workpiece, right? So the function of this flux, what is the function of this flux then? So this flux is due to the formation of heat, or when electricity is passed through this electrode, there might be a chance of oxidation of this metal when it contacts with the open air, so that to eradicate or to mitigate that deposition, that oxidation of this metal when it is exposed to the open air, some amount of flux is coated on this electrode, right? So this is the function of the flux coated on the electrode, and this is how the metal arc welding is functioned. So for metal arc welding, both AC and DC supply can be used. However, AC supply is more preferable as compared to DC, since DC metal arc welding may result in arc blow. Now let us see what is an arc blow. What is meant by an arc blow? See, arc blow is nothing but when a supply is given to the electrode, we know that it forms some arc between the workpiece and the electrode, right? Now when DC supply is given, there is a chance of distortion of this arc from the intended path. We need that arc to be stuck between the workpiece and the electrode, but due to the DC supply, or due to the existence of non-uniform magnetic field due to due to DC supply, what happens? The arc gets distorted from the actual path. So what happens when arc blow happens? When arc blow happens, welding becomes difficult. Why? Because when the arc focuses on the required path, then only the melted metal falls on the damaged part, or the part of the workpiece to be welded or not. Now when this arc blow is happening, there is no, that full concentration of heating is not fallen on that workpiece to be welded. So that to complete the welding or to form a good welding, there will be an increased consumption of energy. So this is the problem with the arc blow. So we can define arc blow as the distortion of arc from intended path. Why it happens? Due to the existence of non-uniform magnetic field. So this is why in case of metal arc welding, AC is preferred comparable with DC. So with AC, the arc blow is sufficiently low. Let me write down, AC is preferred. Right? Now let us discuss the advantages and disadvantages of metal arc welding. Now Now coming to the advantages of metal arc welding, you can see this equipment used for this weld is portable. So very simple mechanism is there. No huge heavy apparatus is there for metal arc welding. So it is portable and also cost is also low. So this is one of the advantages. Coming to the next advantage, so welding can be carried out in any position, whether the metal piece may be horizontal or vertical or diagonal, whatever it may be flat or at any position welding can be carried out, right? This is one of the advantages. So coming to the next advantages, as the filler material is a metal to be welded itself, so we can say that there are number of wide variety of electrodes. So whatever the metal to be welded is, the same is nothing but the filler electrode. So therefore it finds a number of applications. So any kind of metal, if the electrode is possible with the same metal, you can weld that workpiece, right? So because of the availability of wide variety of electrodes, so finds numerous applications, right? This is one of the advantages. So all these are advantages of metal arc welding. Now let us discuss the disadvantages. So coming to the disadvantages, so we know that the electrode is made up of the metal to be welded. So we have discussed this one as advantage, but the same thing comes as the disadvantage also. Why? Because the length of this electrode is limited, right? So due to this limited length of the electrode, and also there will be a flux coated on the electrode. So due to the brittle flux that is not so strong that it must be holded with some electrode holder. So as it is not that strong and the electrode length is also limited, the mechanization of this kind of metal arc welding is difficult. So because of limited length and brittle flux coating on electrode, mechanization is difficult. So there must be a continuous monitoring and continuous replacement of that electrode. Why? Because its length is very small. Also, in case of very long joints, if you want to joint a very long weld, if you have to perform, then this electrode length is limited. That means after the completion of this filler material, you have to replace this electrode, right? So during that welding, the continuation of the welding will be broken due to the need for replacement of this electrode, right? So during the replacement, there might be any defect in the welding. That means it must disturb the strength of that welding part, right? So there may be a defect in replacing, we can tell. So defect in replacement due to short length of the electrode. So any problem while replacement may damage the complete workpiece. That is one of the disadvantages. Now, due to the formation of slag, why? Because a flux is coated on the electrode. So this is a filler material, the metal gets melted, but the flux whichever is coated on the electron may deposit on the welding material in the form of slag, right? So there is a deposition of slag in this kind of arc welding. So this comes as the disadvantages of arc welding. Now let us discuss the applications of arc welding, metal arc welding. Now coming to the applications of metal arc welding. So These are used for fabrication process and also for repairing of metals, mainly repairing to join the two metal parts, right? So next one is this also finds applications in air receiver tank, boilers, and also pressure vessel fabrications. Also finds applications in shipbuilding also. Why? Because in shipbuilding there is a need of welding of long metal sheets, right? So in such cases metal arc welding is applicable. Also buildings, bridge constructions, wherever there is a need of long metals, right? These are also applicable in automotive and aircraft industry. So these are some of the major applications of metal arc welding. Now let us go to the next kind of arc welding technique. Now coming to carbon arc welding. So in this process the heating is done of the workpiece with an electric arc stuck between the carbon electrode as well as the workpiece to be welded. So by heating of this carbon electrode, an arc is stuck between this workpiece and the carbon electrode. So the electrode might be carbon or graphite electrode. This acts as a negative electrode and the workpiece to be welded acts as a positive electrode. So the arc produced between the two electrodes heats the metal to melting temperature. That melting temperature may be up to 3200 degrees centigrade. So the temperature is mostly up to 3200 degrees centigrade on positive electrode, that is the workpiece, right? Now for this type of welding DC is preferred, as we need the polarity, positive polarity and negative polarity, right? So by using AC, proper polarity cannot be maintained, therefore DC is preferred, right? So when the arc is stuck between the positive and the negative electrode, by momentarily touching this graphite electrode with the workpiece to be melted, right? So the arc is made continuous till this workpiece or the metal of the workpiece creates a pool here. That means due to the heat produced by the arc, this workpiece is to be melted up to a certain extent. So here is a pool of the metal. So that means we are heating this up to its melting temperature of this metal, right? So now after removing the arc, after obtaining the required shape of the metal, we are removing the carbon electrode. That means it gets the required material, required shape, right? So that means the welding is done. So in this case the filler rod may be used or may not be used. There is no rule that filler case must be used. So the filler metal and the flux may or may not be used depending upon the type of joint, which type of joint you need. Also it also depends upon which material to be welded, right? This is about carbon arc welding. Now let us see the advantages and disadvantages of carbon arc welding. Now coming to the advantages of the carbon arc welding, so we can control the heat input to the workpiece. Do you agree? How you can control the heat input? By controlling the arc length, right? The arc length is a major factor on which depends upon how much heat is falling on the workpiece to be welded, right? So that is an advantage of this carbon arc welding, that is heat input can be controlled. by what? Arc length. So this is one of the advantages. Coming to the advantages, next advantages, this welding process, that is carbon arc welding process, is suitable for welding of thinner metals. Suitable for thinner metals. Why? Because thinner pieces we can tell. So why? Because if you have to weld a thicker piece, continuous heat must be produced to melt such a thick metal. So it is not suitable for thicker pieces, it is only suitable for thin pieces. As such, we can control the heat input up to the desired area. How much that heat should be penetrated, we can control with the help of the arc length, right? Also, the next advantage comes like total welding cost is less. Welding cost is less when compared to the other arc welding processes, right? The last advantage comes like the process is very simple. Take a carbon electrode, give supply to heat it up to a certain extent that it gets penetrated into the metal workpiece, right? So process is simple, right? So these are the advantages of carbon arc welding. Now coming to the disadvantages. So disadvantages are, there is a chance that carbon get transferred from the electrode to weld. So when carbon gets transferred due to the melting of carbon electrode, so there is a chance that the carbon gets deposited on the welded piece. So when carbon gets deposited on the welded piece, this creates a very hard surface on the welding material. So this generally happens in the case of ferrous materials, right? So there is a chance of carbon deposition which is not needed. Why? Because it makes the workpiece more harder, so it is not needed. So the second disadvantage comes like, as we are using DC here, there is a chance of arc blow, right? So arc blow may cause unequal heating of the metal workpiece or improper heating of the metal workpiece, due to which arc holes may cause on the workpiece, so which is not necessary. Arc blow due to DC supply, right? Right. The next advantages is, sometimes a filler material may be needed. So when the filler material is needed, more amount of heat is required to melt that filler material and fill in the workpiece or not. So that means if more amount of heat is needed, we can tell that it takes more time, right? So we can tell that slow when filler is used, right? It takes more time for the weld to complete when a filler material is used, as it takes more time to melt the filler material, right? So these are the disadvantages of carbon arc welding. Now coming to the applications, let us see what are the applications of carbon arc welding. So these are generally used for welding of steel, aluminium, nickel, copper, and etc. Some kind of alloys also use carbon arc welding, right? So these also can be used for methods such as brazing. So after preheating and post-heating also, these kind of arc welding can be used. So preheating and post-heating of welding joints. So this is nothing but actual welding is done by using some other method, but still at last there might be some need of some more changes in the welding part. In such cases, this carbon arc welding may be used as preheating, and after welding, post heating method also carbon arc welding can be used. This is all about the carbon arc welding. Now coming to atomic hydrogen welding, so it is a welding process in which welding is brought about by an arc stuck between the two tungsten electrons while a stream of hydrogen gas is passed through the arc and around the electrodes, right? So here are the two tungsten electrodes which are placed in metal tubes, right? From these tubes, hydrogen gas is flown. These are steel cylinders, right? So when electrodes are connected to AC supply and hydrogen is supplied from these steel cylinders. So what is the function of these cylinders? Let us see. One is these cylinders acts as protective screen for the arc, right? For the arc to completely focus on the workpiece, these steel cylinders are helpful and prevents formation of impurities. Why? Because when this hydrogen acts with the joins with the atmospheric air, there might be formation of impurities. So they are passed through only the steel cylinders. As such, this is not in contact with the open air, atmospheric air. So that is one of the purpose. Also, this acts as a cooling agent for glowing tungsten electrode points. So this, due to the formation of very high heat, so this acts as a cooling agent, right? Now, when these tungsten electrodes are connected to the AC supply and hydrogen is flown from these cylinders, so this hydrogen, when gets heated, changes into atomic form. So, and these atoms, when comes into contact with the cold base material, this is a base metal, right, on which the welding is going to take place. So when this forms into atoms, a large amount of heat is developed, which is used for making fusion welds, right? This process is capable of producing very smooth welds, smooth, uniform and strong welds. Fusion welds. What is meant by fusion welds? That is nothing but the combination of two metal pieces, right? So by using this method, we can heat the hydrogen to any desired level so that two non-uniform metals can also be welded. So this is applicable for both ferrous and non-ferrous welds, right? Or metals or alloys, most efficient method of welding, right? So the applications comes like welding of thin sheets and also production of tubing, so for repairing of expensive tools also this kind of repairing of expensive tools. So these are some common applications of atomic hydrogen welding. So the next is shielded arc welding. So shielded arc welding. In shielded arc welding, you can see here there are two electrodes to which the supply is given. When supply is given to these electrodes, an arc is stuck between the electrodes as well as the workpiece, right? So when an arc is stuck between these two things, there is a common behavior of the electrode that it is made up of some kind of metal. So when this gets heated, when its temperature rises, there is a chance of melting of this metal. So when this it gets melted, so it may combine with the atmospheric oxygen and nitrogen and may lead to the formation of oxides or nitrates, right? So due to this injurious chemical combination, the metal may become weak such that the weld may be not as strong as we have expected, right? So it may undergo to corrosion resistance, it may become weak, it may become brittle. So to avoid this, what we do is these electrodes are shielded with some kind of things, right? It may be a metal shield, or it may be a flux shield, it may be an inert gas shield, it may be a hydrogen shield. There are different kinds of shields available, right? So this, what happens is, this provides a shield, the covering of the arc, such that whenever the electrode gets melted or the metal to be welded gets melted, it is not directly exposed to the atmospheric air. So this shield creates an envelope of inert gas around the arc, such that it does not react with the atmospheric oxygen and prevents the contamination of the metal, right? So this is the method of shielded arc welding. So this kind of shielded arc welding leads us to a good weld when compared to an ordinary arc or ordinary metal arc welding, right? This is all about different kinds of arc welding techniques. Hope you have understood. Thank you.